Hi everyone. So it is finally time for me to go over the last unit of our trig trimester. Yeah, so let's do that. All right, so let me share my screen and let's start taking a look. This final unit that we have to go over is oblique triangles. What it means to solve for oblique triangles. So we're really getting there. We've done great. We've gone over 4 units so far. Um, we did it at a fast pace, but we've all persevered and we've done really great. And this is our last little bit. And now, like I've said, this isn't going to be a huge part of the final exam, right? We haven't had very much time at all to go over this unit, so it's not going to be a huge part of the exam. It'll only be a few questions, all right? And it'll be kind of one of those things like if you get it, you get it. If you don't get the points, I'm not going to count it, all right? I don't want you guys to stress out too much about this. And there are some parts of this that would be a little bit easier addressed if we had some different units prior. Those are going to be ones that are covered in pre-calculus, and they'll probably also be units that are covered later in the year for um, those who retake trig. With that being said, it'll be okay. You guys are gonna do great. Let's stay strong. We got two topics left, right? We've got one unit, just two little topics left. Stay strong. We got this. We're gonna do great. All right. So this right here, what we're gonna be talking about today is finding the missing side of an oblique triangle. Okay. So our objective for the day, we're going to use the law of sines and the law of cosines to find the missing side of oblique triangles. All right, so notice here, we're going to be talking about some law of sines. All right, so a formula, some kind of formula, and then a law of cosines, a different formula. And then we're going to be using those to find the missing side of oblique triangles. Well, oblique, that's a different word than what we're used to, right? We're used to right triangles. We find the missing side of right triangles either using the Pythagorean theorem or using sine, cosine, tangent, right? But now we're going to be talking about oblique triangles, so we have to use slightly different formulas, okay? Well, that begs the question, what is an oblique triangle? An oblique triangle is just any triangle, as you can see here, that is not a right triangle. Okay, so here you can see in the yellow, that is an example of one potential type of oblique triangle. We have all different types of triangles in this illustration right here. Okay, but we can actually see that a lot of these different examples in different colors are in fact oblique triangles because a lot of them are not right triangles. Okay, and most of the times um, these these oblique triangles that are not right triangles are going to look something like this. All right, these are the main examples that we're going to be doing. It'll be something along the lines of this right here. Okay. So notice that in this triangle right here, triangle ABC, we've labeled the angles as uppercase letters. All right. We have labeled the sides in between the angles as lowercase letters. And then notice that we have attached the same letter to the opposing angle and side. All right, so here, for example, you can see angle A is opposite to side A. All right, angle big letter B is opposite of side little letter b. And up here, angle C, capital C, is opposite of side little letter lowercase c. Okay, this is an example of an acute triangle. And why is it acute? Because all of these angles inside of this triangle are acute. And hopefully we remember that the word acute means smaller than 90 degrees. Okay. Now here is an example of an oblique, or not oblique. It is an oblique triangle, but this is an obtuse triangle, all right? And notice that oftentimes in oblique triangles that all of the sides are different lengths. That's going to be a pretty common thing. So it's not necessarily always scalene, but a lot of the time these triangles are scalene. So again, notice, right, that despite the fact that these triangles look a little different, both of them are oblique, right? They're still labeled ABC, with the capital letters being the angles and the lowercase letters being the sides. And again, the opposite side and angle are the same letter, right? But this is an example of an obtuse triangle. Well, why is it obtuse? Because one of the angles in it is an obtuse angle. So angle A right here, you can see, is greater than 90 degrees. So this is an obtuse triangle. Okay, we're not going to do too many examples with obtuse triangles. Most of them we're going to keep as acute because we're trying to keep this unit as bare basic and as simple as we can since we didn't have too much time to go over it, right? So now quickly before I move on and go into the actual formulas, the actual laws, right, I want to talk about just some different theorems from back in geometry. So this should be from 2 years ago, pulling back some memory. I know it's been a while, but hopefully we remember some of these theorems. So when we were trying to prove that two triangles are congruent using a proof in geometry, right, we had a couple different proofs that we could use. We could use angle, angle, side. We could use side, angle, side. We could use angle, side, angle, or side, 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 right? These were some of the options that we could use when we wanted to prove that two different triangles were in fact congruent, were in fact the same size, okay? Now, another example that we could use is side-side angle, but this we call an ambiguous case. All right, so if we're given a triangle with side-side angle, when we're trying to solve for this triangle or solve for a missing side in trigonometry, this forms an ambiguous case, meaning that we could actually get one or two answers, or we might not get any answers at all. It might not even actually be possible to find the missing side. So that is a little bit a tricky case. That's why it's called an ambiguous case. It doesn't have one proper answer in the way that these other first four theorems will have proper one single answers, right? The side-side angle case doesn't work so well. That's just a fact that I need you to keep in mind, but we're not going to do any examples with that. So with that being said, let's move on to actual examples of things, all right? So this right here is our law of sines, okay? So this we would use for angle, angle, side, or angle, side, angle. So angle, angle, side, or angle, side, angle, right? For our purposes in this class, because we're going to be finding the missing side, we're going to be using only angle, angle, side. We're going to keep it simple, like I said. But this right here, this formula right here in the red box, this is our law of sines. So sine of angle A divided by side A is equal to sine of angle B divided by side B, which is equal to sine of angle C divided by side C. All right, so just notice that these are just different ratios. All right, and we're going to be given an angle, and a side, and we'll be solving for another side. So what does that mean? We have two sets of angles and two sets of sides that we're working with. So that means we're only going to have to use 2 out of the 3 ratios every time we use the law of sines. Okay? Again, we will only be using 2 out of the 3. There's going to be a pair of angles or a pair, or I should say a letter pair, right, that we're not going to need to use. All right, so take a moment, pause if you need to write down this right here, this law of sines, and then we'll go into an example and you guys can see exactly what I mean when I say that we only need to use 2 out of the 3. Okay? So here is an example right here. Again, make sure that because we're using degrees now when we're talking about the angles inside of a triangle, that your calculator is in degree mode. That's super important. Because we're actually using sine now, we're actually using a trigonometric function, right? So sine, cosine, tangent, cosecant, secant, cotangent. When we're actually using those, we need to make sure that we're on the right mode. And because we're using degrees, we have to make sure we're using degree mode, right? Now notice this triangle that we have right here. So we have triangle ABC, right? Nice little triangle. We're given angle B is 64 degrees. We're given angle A is 36 degrees. And then we're given this side right here between angles A and C. This side right here is 8 units long, okay? And we're trying to find this side right here, this side between angle C and angle B. This is X. We're trying to find that missing side. That's what we're going to be solving for, okay? So now we're going to take a look at our law of sines. So sine A divided by A is equal to sine B divided by B, which is equal to sine C divided by C. Again, notice the capital letters are the angles, the lowercase letters are the side lengths. So we have to ask ourselves, well, what's A and what's B? All right, and what's lowercase a and what's lowercase b? So figuring out what angle A and angle B are is pretty simple. It's given to us. So angle A is 36 degrees, right? Angle B is 64 degrees. Now what about these sides? Which letters of sides are these? Well, angle A is opposite to side A. So we know that little letter side A in our formula is going to be x. All right, so there's one part of the formula that we can plug in. Sine of angle A, 36 degrees, divided by the length of side A. We know that side A is x, so that's what we're going to solve for. So we've got one part of our formula down. Cool. All right, now what about B over here? We've got angle B, it's 64 degrees. And that means that side B, again, is opposite of angle B. Side B is 8, and we're given that. All right, so we're going to set this up, right? And like I said, we're only going to use 2 out of the 3 ratios. We only used the pair of A's and the pair of B's. We don't have to worry about C. We're not given angle C, nor do we have to worry about side C. So we're not going to worry about C. We're only going to use 2 out of the 3. So we're going to worry about A and B. So let's plug in B. We plugged in A, sine of 36 degrees divided by x is equal to, and then sine of angle B, which is 64 degrees, divided by side B, right, which is opposite of angle B, so that's 8. All right, and then all we're going to do after this is solve for x. So the first step we have to do is to cross multiply. So to cross multiply, what do? Well, we take the numerator of one fraction, and then we multiply it by the denominator of the other. And then we take the other numerator of the second fraction, and we multiply it by the denominator of the first one. Right? So we'll do sine of 36 degrees times 8, so you can see that right here, 8 times sine 36, is going to be equal to x times sine of 64. We are cross multiplying one numerator times the other's denominator, and we set those equal to each other. So that'll be x times sine of 64. So 8 sine of 36 is equal to x sine of 64. We cross multiply. Right? And now we want to solve for x. So what are we going to do? Well, we're going to divide both sides by sine of 64 because we want to get x by itself. So if x is being multiplied by sine of 64, we'll divide to get rid of that sine of 64, right? To get x by itself. So once we divide both sides of sine of 64, this is what we get. We get 8 times the sine of 36 degrees, right? This side of the equation, divided by that sine of 64 degrees. And hopefully you feel confident enough to just plug that into your calculator, again, using degree mode. And then you'll get that x is equal to 5.232. All right, so this side right here is going to be 5.232. Unfortunately, this triangle is not drawn to scale, but that's okay. That is the correct answer, right? So 5.232. All right, and that's how you would solve for that. So that is how you would use the law of sines. Now here's another example. All right, so again, we've got triangle ABC. We're given that this angle is 88 degrees, angle B, angle A is 22, and now we're given side A. That's 4, and we're trying to solve for side B. So we're going to use our law of sines, right? So sine of angle A divided by side A is equal to sine of angle B divided by side B, which is equal to sine of angle C divided by side C. Again, we're only looking at A's and B's, so we're not worrying about angle C or side C. So we only have to worry about these first two, right? A is equal to B. We don't have to worry about C. So let's just set it up. Sine of angle A, which is 22 degrees, divided by the opposite side, which is 4, right, is equal to sine of angle B, which is 88, divided by the opposite side, which is x. All right, and now we solve for x because we're trying to find the length of this missing side. So we'll cross multiply. So x times the sine of 22 degrees is equal to 4 times the sine of 88 degrees. And then to get x by itself, we're going to divide both sides by sine of 22. So x is going to be equal to 4 sine of 88 degrees divided by sine of 22 degrees. Plug and chug, put it into your calculator, and you'll get that x is equal to 10.671 units, right? Again, not drawn to scale, but that's okay, right? So there you go. This side length right here, side B, right, is 10.671 units long. Right? So that is how we would use the law of sines. Now, let's move on to the law of cosines. So this one is going to be a little bit different. We're not going to be using angle, angle, side anymore, all right? Now we're going to be using side, angle, side, or in some circumstances, you could actually use this for side, 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 but we're not going to use that for our purposes, all right? So this right here in the red box is the law of cosines, right? So before we had the law of sines because we used sine in the equation, right? Now we have the law of cosines, and this is called the law of cosines because you can see right here, we use cosine in our equation. So it's simple to differentiate why those are called what they're called, right? Now notice, we have a squared, so the length of side a squared is equal to b squared plus c squared minus 2 times b times c times the cosine of angle A. Notice that this right here, this a squared equals b squared plus c squared, or even down here, c squared equals a squared plus b squared, right? That looks familiar. That looks like the Pythagorean theorem, right? So all the law of cosines is just a more complicated version of the Pythagorean theorem, okay? So all you have to do is just write these formulas down, all right? It's not as complicated as you think it is. Why? Because everything on this right side of the equation, right, this b squared plus c squared minus 2bc cosine A, all of these b and c and angle A, those are already given to you. They will all be given to you, right? So notice we're going to be using side, angle, side. What does that mean? Well, that means we're going to be given two sides and an angle. So notice on the right side of this equation, right, that in every single equation, there are two sides, right? So here's B and C, two sides, and then cosine of angle A, one angle. We're given two sides and an angle. You are given everything. Here, for example, AC, right? These are little letter A and C. These are two sides. And then the cosine of angle B, two sides and one angle, all right? So it's always going to be, you're going to be given the two sides and then the angle in between. You're going to be always given, right, all of these letters, all of these variables to plug in. They will be given to you. All you have to do is plug it in. All right, and the order doesn't matter too much, but for the sake of keeping it consistent, you can put it in the correct order if you want, right? You can switch up B and C. It's not going to make too much of a difference. All right. And then the same thing applies for all of the lengths of the sides, right? So b squared equals a squared plus c squared minus 2ac cosine b, right? So to find the length of side b, you would just take the square of the two other sides that you're given, and then minus 2 times the length of the two sides that you are given, a and c, times the cosine of angle b. And again, you'll be given angle b, right? So you'll always be solving for the side that pairs along with the angle that you're given. All right, so let's take a look at an example of this. All right, so let's say, again, we're given triangle ABC, and we're going to find the missing side of the triangle. Notice it looks a little different, right? So before, when we were given angle, angle, side, now we're given side, angle, side. We're given two sides and the angle in between, side, angle, side. All right? And we have to be finding the side opposite of the angle that's given. So that's exactly what's happening here. We're given this 70 degrees for angle A, and we're going to be finding the missing side that is across from angle A, so side A. So because we're finding side A, we're going to use the A formula out of the three law of cosines, right? So A squared equals B squared plus C squared minus 2BC cosine of A, right? So now we're going to replace A with X because that's what we're solving for, right? And we're going to substitute B for 4. Why is that? Because side B is opposite of angle B. So that's 4, right? So 4 squared. plus c squared. Well, c is 5, right? C is the opposite side of angle C. So that's the length of 5, right? So 5 squared. And then minus 2 times B, right, 4, times C, 5, times the cosine of the angle we're given, right? So that's 70 degrees. All right, so if you're feeling confident putting 4 squared plus 5 squared minus 2 times 4 times 5 times cosine of 70 into your calculator in one go ahead, that's fine. If not, we're going to break it down a little bit more, right? So x squared equals, okay, 4 squared, which is 16, plus 5 squared, which is 25, minus 2 times 4 times 5, which is 40, times the cosine of 70, which is 0.34. All right, that might be a little bit easier to plug into your calculator. Once you do that, you'll get 27.4, right? But notice that that is x squared. So to undo the square, we have to take the square root, right, of both sides. So the square root of x squared is just x, and then we'll take the square root of 27.4, which is 5.235. So that means that the length of x right here is 5.235 units long. That's all right? Let's try one more example. So let's say we're given, again, triangle ABC. We're given angle B this time, right? It's 66 degrees. We're going to be solving for side B, right? And we're given that side A is 7, side C is 8, and we have side angle side, right? So because we're solving for side B, we know it's side B because it's opposite of angle B. We're going to be using this formula right here. B squared equals A squared plus C squared minus 2AC cosine B. And then we just plug in our numbers. So the length of side A is 7, so 7 squared, plus the length of side C squared, the length of side C is 8, so 8 squared, minus 2 times 7 times 8 times the cosine of angle B, which is 66 degrees. All right, well, 7 squared is 49, plus 8 squared, which is 64, minus 2 times 7 times 8, which is 112, times the cosine of 66, which is 0.407, right? So you plug this into the calculator, 49 plus 64 minus 112 times 0.407. All right, you'll get x squared is equal to 67.416. And again, this is x squared. So remember that when you're using the law of cosines, you're working with squares. You have to remember to take the square root. That is super important. So once we take the square root of both sides, right, we'll take the square root of x squared, which is just x, which is what we want, and then we'll take the square root of 67.416, which is 8.211. So the missing length of this side right here of side B is 8.211 units. All right. And then these are two examples that you guys can try on your own. You can pause right here if you want to know, if you want to figure it out for yourselves. All right. But that is everything. Oh my goodness. Sorry, I'm not going to cut that out of the video. But yeah, all right, so that is everything for finding the missing side of an oblique triangle. Up next, we're going to do finding the area of an oblique triangle. All right, so if you have any questions, let me know. Hopefully this video helps.